Okay, thank you, Thelma. So this is a table of contents. So you see, it's trying to organize itself, right? Then you may have pages which have, like, let's take this page. Page 4, right? Page 40. If you take page, let me see which page is this. No, it's not page 40. Let me see.
Dog is page 40, but it didn't capture that part.
It's 25. Didn't capture. Okay, so I couldn't pick that part. Okay. All right. So the point is that based on the pages and what it can pick, like this one, 54. Let me see what is on page 54. So this is page 54. It has tried to extract some portions of the data, right? Page 54, it picked them bit by bit. So it tried to break them down. You see, it's picked each of the tables. They were separated. So it's picked each of them separately. Page 55 is this. So it will try to organize itself, try and pick every single data. So if you want, this is languages being spoken by people in the country. We'll try to pick all of them. Now, it's a typical PDF file, which naturally, but it's trying to do all of those things, okay? Let me see, okay. The raw pages too are here. Let me see what it gets out of, so this is the raw pages. This is page 40. Let's try to pick the raw, stuff like that. So this is one form, okay? It may also pick different data from in different ways, okay? So if you had an Excel sheet, for instance, it can also pick a typical Excel sheet, okay? So if I have a typical Excel sheet, this is, I think this is you guys, your data. So this is a typical Excel sheet. It's trying to pick that. Yep, it's you guys, right? It's not Louisa and the rest, they're all here. Okay, this is your data, those who accepted, who are pending, all those kind of stuff like that. So basically, it tries to bring the data from different sources, okay? Irrespective of whichever source is coming from and the format, the structure it is that is in, right? It tries to bring them and it tries to help to make sense, okay? Just a minute, guys.
Please, Doc, we cannot hear you.
Oh, I asked you to excuse me. There was an incoming call, so I just had to pick. All right. Sorry, guys.
Oh, all right. Thank you.
Okay, so like I was saying, there are different things that you can do. This is Excel. If you have a typical JSON, okay, so JSON is a data type format, right? We will soon learn about JSON. It's a data type format, okay? There are so many data type formats, okay? That is why I keep on saying that the step 2 is the most tedious of the work. They'll come in different forms and you have to bring all of them together and let them work together. Okay, it's not an easy task, but the tools are there to help you to do some of these things easily. And no wonder they pay data analysts good job because it takes a lot of effort and time. Okay, all right, great, wonderful. Any more questions before I continue? Okay, great. So we will go, when we get there, we'll go a bit deeper and see how it works. All right, let me move on. So that's how crazy the data engineer's job is. All these funny data from every point and everybody, he has to make sure that all this data comes in, all right, and organizing them. And because of that, they also deal with a lot of infrastructure work in terms of hardware, because all these things have to be stored somewhere, right? And so sometimes they have to help in managing some of the servers, some of all of those things. So it's not an easy task. It's a Herculean task for them. They also make sure, you know, when the data, the one we just put, it may not come in the way you want. So you must clean, you must transform, you must prepare the data. So that's their job. They are the guys who keep the gates and ensure that all of us, so far as data is concerned, we are conforming to the master data and the rules that come with it. Okay, good. Any, is it, I hope everybody's okay with this. If you're okay, I'm moving on. Please.
Yes, Doc.
Yeah. If you don't ask and we move on, don't come blaming me. Yeah, somebody was trying to ask a question. Somebody was trying to talk. Oh, go ahead. Okay, that's fine. If there's nobody, then all right. So what are the skills required of a data engineer? You must be good in programming. Programming is critical. Like I said, you want to crawl the web. If you want to crawl web pages, you need to be able to know some Python and stuff like that and be able to use them to crawl the web for your information that you're looking for, okay? You must also have a good knowledge of system architecture, right? Database architectures, things like that. It's very, very important for a data engineer. But that's not what we are here for. But you will learn along because in Ghana and in some places, you end up being jack of all trades, master of none. Before the organization even realize they need to separate the data engineer's job from that, you are still doing it. So like Menleaf said, he was not taught in school, but he has to assume the position by force. So it's important, right? Good. They need to understand what we call the relational and non-relational databases or data stores. What is relational? When you have structured data where you can store in columns and rows, like I talked about, that the database that keeps that is called a relational database. Why relational? Because there are columns and rows, we can have maybe like the one I was talking about, like the student one. We have a table, we have a database that keeps track of all student academic records or examination records. So the student ID is in there. We have a database that keeps track of all the e-learning information. So your student ID is there. Now we can link both of them. There is a relationship between that database and this database. Or if we talk about typical tables, you say there is a relation between this table and that table, right? Based on the student ID, you can link them up. That allows us, that the database that keeps these things, where ensures there is a relationship between two things like that, we call them relational databases. And the ones which keep non-structured data and sometimes, let's say, semi-structured data, where there is no direct relation, because unstructured data is very difficult to relate to them, right? Because of the format in which they come, binary, base 64, things like that, like we saw, the videos and the rest, it's not easy. Those ones are stored in non-relational databases or non-relational data stores, okay? That's how we call those ones. We will go into relational and non-relational databases, I think in the second, in the when we do fundamentals of big data. But oh, sorry. So we'll go into that when we do that. Okay, great. So this is some of the things that the data engineer needs to know. Now, the next key player that is where our job is primarily hinged on, is the data analyst. But today, most data analysts also end up doing some data science work. because the tools have become more sophisticated for, and it makes it easy. Now, what does the data analyst do? We inspect and we clean the data so we can be able to get insight. So normally the data engineer is concerned with his data at a certain level, right? Looking at a big organization, that kind of stuff like that. He is not so much interested in the problem that you as a data analyst is solving for a client. No, that is not his worry. He has presented you data in a way that is clean, a little bit enough. But the way you want to use the data, that is not his job. It is your job now to pick the data, put it directly in the format and the way that you want to be able to work with to solve a client's problem. Now, when we come to the problems that we try to solve, there may be problems related to correlations, okay? So correlation, when we talk about correlation, so this is where the statistics people start coming in. When we talk about correlation, that means that there is a relationship between one variable and another variable. Then let's say there's an independent variable and a dependent variable, okay? So let me give a typical example. What is a dependent variable? Let's take a typical example of, the performance of a car, or let's say our financial performance in an organization, or let's say our operational performance. Let's do operational performance. How do you measure operation? How are you able to get operational performance at top notch? In this case, operational performance becomes the output variable or the dependent variable, right? Then you have things like, if you want to measure, be able to get good operational issues coming out, means that you have to ensure that there are vehicles available. Let's say you are doing deliveries. There are vehicles available. You have to ensure there is fuel available. You have to ensure that the staff are maybe are picking their things early enough. Their dispatch riders are picking their things early enough. All these things are input variables that determine the output variables. So the input variables in this case become the independent variables that are feeding into that. So at the end of the day, you try to establish relationships between the output variable and the independent variables. And in this case, we say that you are trying to establish correlations between them, okay? Right. Sometimes you might not be correlations. You want to find patterns. You look at things like the MTN one I talked about of the Galamsey thing. There was no correlation directly between mining and the economic activity per se. But, sorry, not mining and economic activity. There is no direct correlation between mining and then MTN's job. However, some way, somehow, they realized there is a pattern occurring. And the pattern was not normal. And because the pattern is not normal for Momo transactions, it doesn't mean Momo transactions are not happening in that place. It happens every day. But this pattern is showing it's out of the norm. Therefore, it means we can go investigating to find out the root cause. So the data analysts try to find patterns, okay? And we try to apply statistical methods in trying to do a number of these. We try to apply statistical methods in trying to do a lot of these things. So that is the data analyst job. And finally, we visualize the data, we interpret it, and we present the findings. So in most organizations, that's why the data analyst is very powerful. Most of the times, it's the data analyst that they will take to a meeting to present the work. Sometimes the data analyst or the business analyst or the BI person. So goes out there to try to present the results so that people can understand. Because you see, nobody cares about your decision tree and all the formulas you use behind the scenes. They care about what you are presenting to us. What will make sense? We don't want to know what you did behind to get us here. We just want you to visualize nicely and tell us what it is. Okay, great, wonderful. Let's look at some of the questions that data analysts try to answer so we can get the difference clear. So a typical example is this. Are the users' search experiences generally good or bad?
with the search functionality on our side. Maybe you introduce a new search functionality. You know, let me give a typical example. WhatsApp sometimes changes some things. Recently, they did something. I was looking for, I think they did some update, I think about 2-3 months ago. And you could not find, I think on the status thing, you could not search, right? You could not search. It was very difficult to search. You have to scroll everything, right? So in introducing such a functionality, you might want to test to know whether people are having good experience with it or not. So you might just throw in a survey, a small survey, where people are passing their comments and stuff like that, and then you record. Based on that, you're able to establish whether what you have done is serving its purpose. So this is a typical question that a data analyst will try to answer. Very simple. Sometimes you might want to know people's perceptions, okay, about certain things you've done and things like that. Try to establish correlations, okay, between maybe one product and another product. Most people who buy a laptop will normally buy maybe a bag. So you want to establish that. These are questions that data analysts try to answer. But in today's world, I see a thin line between the data scientists and then the data analysts. Sometimes, most of the times, you see a lot of them crossing over into each other's territory to work. So, because the world is more sophisticated and there are more tools to make our work easier. So, what sort of knowledge do data analysts need? So, the first thing is that a data analyst needs to know things like spreadsheets. Okay? Your Excel, your CSVs, things like that, you need to know. Then also, you need things like writing SQL statements. So databases, you need to know databases. You need to be able to query the databases. You need to do things like that. It's very important, okay? So you need that's the programming aspects also, the IT and programming aspects, so the database. Then you need to also be able to use statistical tools, okay? To be able to create your charts, your dashboards, and other things. Typical like the Power BI, which we are going to use, like your R you're going to use, like your Python for data science that you're going to use, okay? And your programming skills needs to be on top. Your programming skills is very important. So in this course, that's why we have a lot of programming in the course. You do DAX. DAX is a typical language for programming in Power BI. You do R programming and you do Python programming, okay? Great. Now, finally, when you have done this and all your dashboards are out there, you need to have a very strong, not before, for the analytical, you need it before storytelling. You need to be able to see things beyond the norm. You need to, analytical minds see way beyond. So sometimes, the average human being thinks very simplistic. Very simply. That's why magicians can trick us easily. Most of the magic they do, magic shows, it's just tricks. Because the minds, most of us, our minds think very straightforward, very simple, very straightforward. From A, we go to B, from B, we go to C. That's the way we are. But analytical minds think outside the box. So you need to have such a mind, okay? So in this course, you gradually have to build up that skill. Then your storytelling skills are also very important. We'll cover storytelling at the tail end. Storytelling is very important, how you tell your story. Because let me give you a typical example. A typical example is the same thing, how you present. Let's say you go before a president to present something. The maximum you have is 10 minutes, 5-10 minutes. Because he doesn't have time waiting for you. There are many people sitting in the queue. Sometimes 3 minutes. You learn about making like, a PowerPoint, that kind of stuff, okay? Making a statement in a twinkle of an eye, okay? Just within under 1 minute, under 30 seconds, you should be able to tell the whole story of something you've analyzed for years. And people should buy it and should be able to run with it. So you will learn that. Last year was part of the exam. Okay, so these are some of the skills that the data analyst. Now let's look at the data scientist. Data scientist normally goes a bit deeper. Okay, so in this course, you have both data science and data analyst things that you are learning. Okay, so you learn some here, learn some here. That's why I said there's a thin line now between the two gradually, but data scientists go very deep, very deep, very deep. Most of you, if you talk about going very deep, some of you will leave us behind. You leave and walk away. So the first thing for a data scientist is should be able to analyze the data and give us probable courses of action, okay, based on the insights you are seeing. The next, and that's a major function of the data scientist, is predictions, okay? Deep learning, AI, stuff like that. Being able to create these kind of predictive models, predictive and prescriptive models, very important. So in the second semester, you do predictive and prescriptive analytics, okay? Nana will take you through that. Sorry, predictive and prescriptive modeling or analytics, basically. So that's a data scientist. So let's look at the sort of things the data scientist might want to, questions he might want to answer. So for instance, this is a prediction. So based on past data, what would be potentially the number of people who follow me next month? You should be able to tell. I mean, let me give a typical example about Ghana. Look at the football we went playing. At the very onset, the first match, we all knew where we were heading. We were praying for miracles, but if you are using the data to analyze, the last time we won an AFCON Cup, that was an African Cup of Nations Cup, was 1980 or something, 19 something in the 80s. So potentially you're likely not to win because the data doesn't tell us that you win. Typically, if you go to the World Cup, you are rest assured Brazil, at least they will appear in the finals. So you can predict based on past records. Okay. And that's what the data scientists try to do. They try to make their predictions based on previous data. Okay. Very important. Now, then we do have questions like, okay, if you have a churn out rate, a churn rate among your customers who are coming to, let's say, Melcom, they come to shop, buy things, go and stuff like that. You want to answer how many people are you likely to lose in the next quarter based on your previous data, right? Okay, all right. And then things like, let's say your typical Visa card, you put in, normally, I think Visa has 3 seconds to detect whether your card is a fraud or it's not a fraud and reject you. So these are things that the data scientists try to answer. And okay, I think, okay, 1 minute. Guys, sorry, I think I missed something in my slides. Oh. Just a minute, I'm coming. Please, 1 minute. It's all right. Let's continue. I'll cover that later on in another list. Okay, so this is basically what the data analyst. So we've talked about the data scientist. The BI person basically hinges on the analyst and the BI guy. Basically, they rely on the work that has already been done by the data analyst and the data scientist, and then they look at it and then try to help organizations take decisions and make recommendations. Okay, so normally they come in when everything is done. So they just try to make use of the data to help organizations shape themselves better. All right. So that's the data analyst, the BI, and then the data analyst primarily. Okay. So they normally focus on how to make the organizations gain profit, things like that, a competitive advantage, among others. That's it. They pick the data and just they pick the reports. Let me put it right. They pick the reports and try to help organizations shape up well. So they are more hinged on the storytelling perspectives, largely. Okay, good. So in summary, we say that the data engineers convert raw data into usable data for everybody in the ecosystem to use. The analysts, they try to use the data to generate insights. Okay. Then we have the data scientists, okay, also trying to use data analytics, okay, and the data engineers things to predict and make inferences based on historic data or past data, okay. Then the BI guys normally pick the insights and predictions that exist, and then they try to help organizations grow or make decisions. So that is it, right? Good. All right. Any questions before I continue? Any questions,
Doc.
please? Yeah, go ahead. Yeah.
Yes, Doc. Yeah, so as you mentioned, in Ghana, our system is quite different. You find the person doing all these jobs, most
Yeah.
likely being the data engineer, data analyst, and data scientist job. So
Mhm.
what name will you give to such a person? Do you have a special name for such people?
Most organizations will still call you a data analyst.
Oh,
Most
okay, okay.
organizations I've seen, that's why they end up, they'll call you a data analyst. Or sometimes some will say system analyst. Some, I mean, be out to in Ghana, you don't have
Yeah.
because the guy, the HR guy who is trying to form the names does not even understand the field. But he's the HR person. So when you don't go for meetings, do you go for management meetings? You don't.
That's true.
So
Don't,
what
yeah.
they research more and they come up with, they give you, and you take in good faith and walk away. You understand what I'm
So
saying?
where does I do. Where does the database administrator comes in this?
Normally, the database administrator work sits at the data engineering perspective. But I must be honest, all these people do databases, so everybody does it. I mean, you see, one of the central things about this work, and that is why you are doing this course, right? We'll teach you everything. We won't leave some out. Because we understand the nuances of the African setting. In developed and advanced countries, and I don't blame us, most of our organizations are small, but they still want to behave big, right? The multinationals normally will not have this challenge because you see, over the years, they have established the IT sections and the analytics, and so things are structured. So they will segregate. Look, let me give it, those who are IT guys here. When we started, we everything. I think we should write a book. Hey, yeah, I am going to see a match.
I do.
I only ever kind of story that, but we've gone through the mill to understand, you know. And the truth is, let me give you a typical example. Let me just give you a history of how this course even came to be. So I finished my PhD. I did my PhD in information system, but my work was on big data analytics, right? And so came back, I saw the future. I saw that, look, if we don't start organizing and get people in the space for this, look at Dubai is now picking a minister for, I've picked a minister for AI for almost 2 years or 3 years now, right? I mean, if the world power blocks and people who matter are picking ministers for AI, and we are still crawling and thinking whether we don't even have a master's degree or even let alone an undergraduate degree in it. You can imagine, right? So I decided to do this. I was happy to have a dean, Prof. Bosu, who understood the dynamics of the era. And so has been advocate for some of these changes. And so we ended up where we are. At least understanding the space, having worked with databases, having worked with all of that, doing big data and all those things. And my big data topic, course, I picked 2014, Tom, when now it was coming. Even my supervisor, one of my, I had two supervisors. One supervisor said it's not possible. The other said, John, I don't understand, but I have faith in you. Let's go. And that's where we ended up. So really, in a part of the world, it would take some time. It's simply because people are skeptical because they've not been exposed. In the developed, it's the same thing even in the US and the rest. It takes time for most of them to come to terms. So Oga, the database guy says you need to learn everything now because of where we are. You are the next, you are third, you are fourth or third batch. I'm not sure of the years now, I've lost track. You are, I think, our third or fourth batch of data analysts, data analytics people, right? When we started, the numbers were very few. This year, you're almost 70. And it's fast growing. In fact, last year, they were 32. Now you guys are 70. So you can imagine what I mean. Do you understand me? So awareness is coming.
Yeah.
People are moving to the field. Organizations have become more aware. Thank God for AI. Everybody is becoming much more aware. But when you start everything, everybody, people, you know, sometimes I have had cause sometimes to defend somebody like Baumia on pages. And when I defend it because I am an IT person and I see the change in the digitization perspective. But when you are sending it, like I said earlier, when people will come from a political angle, they won't even see what you are saying. But the generational changes and thinkers are like that. When 10 years from now, when the person is not there, people will then appreciate, oh, this was what the person was trying to do. Nkrumah tried to do many things we all didn't understand. Today we thank him and praise him as if, you know what Nkrumah went through? Why do you think they overthrew him? People just couldn't understand what he was doing. When he was building Independence Square, they insulted him. What are you building this large place for? Today, where do we all hold the programs?
Yep.
Yeah. So I don't say that our system has changed. It's changing. And it's because of some of these things we are gradually taking steps towards. Now, today you are clear. I'm sure before this lecture, you might not have realized there's a data engineer, there's so and so, there's so, but now you know, right? So next time you are in an organization, somebody comes and say, I'm a data engineer. Say, you two, what do you want? Or maybe you have a very sophisticated HR person who say, look, this job is not the job of the analyst. Can we have data engineers who will sit in this and do that so that we can make things more efficient? When you have just an employee of 10, 5 people, you don't think of data engineers.
What you were saying, even, but I started thinking about this, that why was this course being offered by the business school, not the computer science department? It's something I started thinking about.
And it's primarily because, you see, analytics is meant to answer business questions, or the questions that is answering, not the technology. At the end of the day, your CEO doesn't care about the technology. Do you know that?
Yeah,
He
it's
cares
true.
about
They don't.
yes, that's why when I got here in my slide, I put there the questions that each of these are trying. What do you think your CEO doesn't care about your predictive modeling and the rest, right? What you care about is how
Yeah.
many people am I likely to lose in the next quarter based on the state of the economy. If you can give him projections and the projections are accurate, he'll keep you at his job. Look, I have a friend. Let me just show you this guy. Am I sharing my screen? I'm sharing. Let me share. Okay, it's my screen. This is a friend of mine. One of the few a lot of people lost their jobs in COVID, but I'll try and get John. I'll get John to talk to you guys. This is Atimo, right? He's a colleague of mine. Okay.
Okay.
And this is Atimo. Okay. He's done a lot of analytics work, actuarial analytics, all that kind of COVID, he was one of the few people who was still earning, the digits we are talking about, good digits, right? A number of people lost their job, but he did not. Because he's built his capacity, clearly. I mean, you see the profile, right? And it's because he's an analytics person and he's strong. So don't worry if you're a jack of trades, of master of man. He began as mathematics at Legon and gradually rose all the way to the US and stuff. But what I'm putting across is that sometimes you start off a very unorthodox approach, but stick your guns to it. And the time is coming where all the segregations will come to play in the organization. When the organization has grown big, right? When it's small and it's starting, you do all the things. Do you understand me? So it's fine. Jerome, you wanted to say something. I saw you.
Yes. Good morning once again.
Good morning, Jerome.
I just wanted to ask what the impact is, since you mentioned it's AI, with each of these key players in data. For example, I don't know, but there's this thing Microsoft is doing, Copilot.
Yeah.
And from the way it's going, it's more or less taking the job of the data analyst. So I don't know if you could just maybe clarify it. How
It's not taking the job of the data analyst. Look, let me show you what I do with my chat. I don't even like Copilot. Copilot is weak. Unfortunately, that's my conclusion. If I compare BAD, I compare Copilot, I compare ChatGPT. That's why Microsoft has partnered ChatGPT. They invested $10 billion in ChatGPT, in OpenAI, right? Because every AI relies on data. And actually, if their partnership was not there, like by now, ChatGPT will be gradually dying. Because the data was old. Previously it was up to 2021, right, Jerome? Do you know that?
Yes, I'm very, very much aware.
Whilst Microsoft had data because of its Bing search, it didn't have a strong technical team to make use of the data and present it. So when Copilot started, I'm on Copilot anyway. When Copilot started, it was just weak. It's weak. So that's my Copilot, right? So Copilot is there, but if you use Chat, you use Bard. So have you tried Google Bard before?
No, not yet.
Try Bard. Bard is very recent in terms of so this is Google Bard. I don't know whether they will allow you easily in. And please, this is an advice to all of you. Anytime any of these are starting, sign up very early. When you hear it has come, sign up before it's too late. Now, I know some of my colleagues who went in for trying to sign up on I think ChatGPT now. They are holding their accounts still stay there because they too many people are on now, so the capacity for new customers is limited. Sometimes you just sign up early. That's my Bard anyway. This is my Google Bard. So Google Bard will pick things from your drive, everything. It's the same thing. Whatever you can ask. What is the state of data? I'll put a question there. So I'm trying to use this to. Oh, sorry. Let me see whether I will be able to correct it. Okay. Okay, so this is typical Google Bard, right? So it does similar things, just like your typical chat would do, right? Or Copilot would do. But if you take Copilot is now running on the back of ChatGPT, and they will tell you that. So that's it. And if you go so they've integrated the two. If you take chat, your typical chat has Bing. Oh, sorry. Your typical ChatGPT has Bing now. Let me look at exploring. This is a paid version, so Um, Search. Okay, let me pick a typical site like this. Bring it here, put it here. It will try go browsing. So when it tries browsing, you'll see it will try doing research with Bing. Have you seen that? Have you seen that?
Yes. Yes.
So it will go to Bing, and so they've integrated, and because of that, both are helped because chat that OpenAI doesn't have data, but Bing search has data. It crawls. It has been crawling for years, so it has whole lot of previous data. Now, even that one, what is your current cutoff point of data? What's your current? I think it's January 2022. Okay, good. That's good. At least it has come forward a bit. The last time I think it was January. Now it's April 2023. On the other hand, BAD is very accurate. It's very now, because it belongs to Google. Do you understand me?
Yes, I
If
do.
you should ask this anybody who was appointed in July or September something, ChatGPT cannot tell you. It can't tell you. Now, and I like a question, the role of it in the different professions. It's very important. Now, because the AI models are becoming more sophisticated, if you explore chat, for instance, OpenAI has opened up for different people to use it in different ways. Okay. So all these things are being done by people. This is a typical one for a data analyst. Okay. If you are doing analysis and stuff like that. So people are integrating these AIs based on the APIs that they have. If you want, I think OpenAI has a developer site if you are interested. Yeah, so they have this their API, right? So you can have an overview of it. So developers they allow you to use the APIs now. A lot of prompt engineering and stuff is ongoing, right? Great. Okay, please let me go on to the lecture, but I guess you get my point, right? It's if I'm a data engineer, I want to use it. I'll write APIs which can help me do this work much more easier, right? Good. So there are a lot of them out there who are making use of them. Now, there's a buzz and a craze. Everybody wants to use AI in his work to make life much more easier because the AIs make it easy to put data, aggregate data. So for instance, this same thing I was using Power BI to do. The only problem is that these guys may not be able to deal with very large, excessive volumes of data, if you are, like connecting to a live feed of data, flowing in, that kind of stuff. Let's say the whole banking data of, let's say EcoBank. I mean, EcoBank will not expose such a data to OpenAI straight away. Do you understand my point? They won't do that.
Yes.
The only thing is now I know they are gradually bringing there are different plans. So now they are doing team plans. They used not to have team plans. They are trying to do that. Gradually they are heading towards where they can allow businesses to come in with their own things and stuff because of privacy, security, and all these complications which come with the data. Compliance is a big issue in data. So you may have dreams, but your dreams might not be realities for now because the rules are there. In fact, right now, I'm working on 2 projects. I'm very careful to use OpenAI. One is the one I'm talking about, the AI for justice. So because of that, we are going the route of trying to do GAN models ourselves. Because if we don't do that, my worry is if we head towards that direction and that OpenAI is controlled by the Americans, right? At the end of the day, their HIPAA laws are very strict when it comes to their ethic laws are so strict, right? So before you realize you want to use it for something data on Ghana, but they say you can't use it because it's going against it's violating our ethics. Jerome, do you understand me? So you can use them, but the only thing is that they are being used by people, by different sets of people. So it all depends on how you want to use it. Okay. All right, great, wonderful. So moving on. So, but the key thing is that all these people's works are interconnected. Like I've just shown you, they're all interconnected. There is no isolation out there. Okay, so let's go to data analysis itself. Any more questions, please?
Sir,
Yes.
no. So where
Yes.
does the MIS what role does he play in it, the MIS?
MIS.
Yeah, management information
MIS.
system.
So MIS is a. So let me put it this way: MIS is is big. Okay. You know, I mentioned the storytelling. I mentioned the data engineer. MIS where cuts across, right? But you're managing an entire system. And an entire system consists of different people. Data analysts, you blah, 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 IT people, everybody. So far as there is an IT system in place, there is an information system in place, an MIS person is called to action. But the thing is that as you work in MIS and the terrain is changing, sometimes you also want to evolve. You say, I want to just focus on maybe so and so, right? Or I want to focus on so. So you realize most people in as MIS people might perhaps even end up being the chief data analytics officer of the big organization that they are in, because he's trying to narrow down his area and mastered in it. You know, just like typical MIS, previously we didn't have chief information officers. Now we have CIOs, right? Years ago we had CTOs, right? Now we have CIOs. So MIS basically is about managing all these things. It's a management perspective. Are you with me?
Yeah.
MIS is not the same as data analytics. So
Okay.
please don't confuse the two. They are not the same. MIS is managing the system, and in that system is data analytics also. And in that system is systems administration in that system is the cyber security issues. Do you understand me?
Yeah.
So MIS is far much more bigger than we think. It's a bigger place. But the truth is that all these things, that's why this is situated under our department, information systems and supply chain department, right? Okay. Any more questions before I move on? Okay. So now we are moving on. What is data analysis? So we've talked about the ecosystem. We talked so much about data. Now we're going to the analysis part. Okay. Going to the analysis part. Now we'll deal with the mathematics related to the analysis, the mean, the mode, the median, the variable types, qualitative, quantitative, independent. I've mentioned a few along the line. But when you deal with the mathematics perspective, all these things will come to the fore. You understand them. So, but if you ask me questions along, I will. But those aspects, I'm leaving in the hands of the mathematicians to deal with you, or the statistics people to deal with you. But along the line, if you ask me, I will. All right. So what's data analysis? It's the process of basically we gathering the data, we analyzing, we mining the data, looking for insights, patterns, and the rest. We interpreting the results and reporting the findings. That's what data analysis is about. 3 things, key. Okay. And if you notice, these 3 things are what governs the data ecosystem, true or false? It is. Because you source data, you bring it in, you clean or standardize, and then finally, you make it available for users through your findings, through your reports, through things like that. So that's data analysis for you, right? So that's data analysis primarily. You find patterns within the data and then you present it so that people can appreciate and understand it, okay? Good. Now, why do we do this? There are so many reasons why we do this. There are so many reasons why we do this. And so it is very important we understand some of these reasons, okay? So we have past performance. We want to understand where we are coming from why we are here. And I'm sure, Menlive, your bosses, that's what they are interested in, right? Your bosses are interested in those things. I'm very sure that's what they care a lot about, right? Good.
Yeah.
So they don't care about they want to see, oh, how much did we mine today? How much are we going selling and those things? They want to make decisions quickly with those ones. Okay, so decision making is important. Now, the other thing also that is important in that space is you want to ensure that if it's operational performance that you are focused on, you are able to say that what resources should we allocate to this? What should we do this? On my other machine, I have a Power BI thing there where I analyze, some of the systems I build, we do a lot of analysis. And we analyze some data for a particular entity to make the case to the board that, look, online sales is where you should go, right? Because look, you can make more money through online sales than you can sell more. You can sell more through online sales than through the traditional approaches. So when we analyze that data, I mean, when they started their online sales, just a small volume of it was online. By the next year, the online sales are taking up almost about 40% of their sales. The next following year, we had almost over 60% of the sales. And the data, because the data is there, the board people could see it. And they were visualizing it in charts and stuff like that. They could drill down, they could go inside, understand branch by branch, region by region, things like that. And they were excited and they were like, oh, then we have to invest more. In fact, I had a meeting with those people just about a month or two ago. And then one of them said, look, we are meeting because the system has become our revenue assurance system. That's our main revenue assurance system. Without it, you can't see your sales. You can't see where you are going. And that's what management wants to know. That's why they invest in these things, okay? That's why data analysis is important. Sometimes you want to solve problems. You want to create new models. You want to come up with different businesses, new business models. And therefore, you are pushed towards that direction to analyze your data, okay? Or sometimes to increase efficiency, okay? All these things are wonderful things and reasons why we do that. And ultimately, you want to influence policy and a whole lot of other things within the space. All right, let's move on. Okay, that said, we talk about data analysis, how it helps, but there are different types of data analysis. 4 types of data analytics, okay, or analysis primarily. So the first is descriptive analytics. In Ghana, most organizations do a lot of descriptives. So there's a lot of descriptive analytics, right? And for the first part of our lecture, we'll do a lot of descriptives. That's why we're starting with the Power BIs. So do a lot of descriptives and stuff like that, but it will still present some good insights, okay, based on the past events. Now, the next set of analytics, and those ones, let me give a typical Splunk. If you've used Splunk before, anybody used Splunk before? Let me see. Hold on. There's a Splunk. Okay, this is Splunk. Splunk is a tool for so this is Splunk. Can download and try Splunk. So it's free. You have free Splunk here. You can download. Splunk does a lot of causative or a lot of diagnostic related analysis. Okay, so the typical of the IT guys, you can use when you install Splunk on your machine, for instance, on a server, for instance, you can pull all potential logs which have ever happened on your machine before. The system keeps track of all this. Your machine keeps track of all these things. And based on it, you can observe the relevant metrics around it, see how things are, and be able. So this is a typical example. So Splunk is another tool which is very good for diagnostic analytics. Diagnostic basically looks at what happened. Okay, so it puts the data and tell us what is causing something to happen. Okay, right. So it goes slightly a little deeper than what happened. Why did it happen? Okay, so it takes the descriptives and dig a bit deeper to understand the causative reasons. Okay, so you can download Splunk, try it out and see. So that's for diagnostic analytics. Then we have predictive analytics. Predictive analytics basically is looking at what will happen next. So if you remember the data scientist question here, these questions, there were some questions here. Oh, where's the data science guy? Yep.
Doc, your screen is not showing. You have
Oh,
to repeat.
sorry, you guys, sorry. Okay, so let me come back. Here was where I was, right? Okay, good. So I said the diagnostics are why did it happen, right? And then we dig, it's about causative, right? Causative. Not, you're not just observing what is telling you. You are trying to unearth why it did happen. You know, in Ghana, many things happen and we don't try to find out why it happened. And for Ghana, even if a person, an old lady dies at the age of 85, some witches kill them. Right? Or is it not true, guys? And for Ghana, nobody dies a natural death. They will look for some explanation why the person died. And they will go, we always want to blame somebody for the death. But you go deeper and the causative aspect might not even be the witches. In fact, I don't know why when everybody grows, when we are young, when a young lady, nice, you know, is walking around, the person is not a witch. At 23, 20 something, 30 something, is not a witch. 40, not witch. The moment he turns 70, 80, and then they all turn witches. Hey, Ghana, God help us. So diagnostic analytics helps us to deal with the causative perspective. Then we have the predictive analytics. Predictive analytics gives us more value. In fact, the trend is such that predictive analytics gives us more value, right, than the diagnostic and the descriptive. So predictive basically is looking at what will happen next. So that's where I was trying to take you back so that you see some of the questions the data scientist, for instance, was trying to answer. Okay. How many social media followers am I likely to get next? And that's a prediction. It's not accurate, it's a probability. Okay. It's not that it will definitely happen, but there's a 95% chance that. And that's why you learn things like the statistics are, you have 95% confidence level. Okay, that means you are very sure that this thing's likely to happen. So if you do get a relationship and stuff, and then you see that it's quite significant, the statistic people, you therefore know that this thing is likely to happen. And most of the times it will happen. Like the predictions in rain, it's a similar thing. So they predict based on historic record and then the current data they have. They merge everything and are able to make a prediction and tell you that this is likely to happen. So you will learn a number of that, and most of them, I mean, we'll do some predictions with Power BI. We will. Okay, we'll do predictions with Power BI. So we'll come across it. So Power BI is able to make predictions on its own based on historic data. It might not be very accurate, but it does. The R's and the Pythons, when you integrate them, give much more better results than your typical, just the raw Power BI. Okay. All right. Then finally, prescriptive analytics. Prescriptive goes beyond just what will happen next. It gives you a recommendation. Okay, in case you take this course of action based on what will happen next, what will then happen? So what should really be done about what the prediction you have made? Okay, so you analyze the past decisions, you estimate the likelihood of different outcomes, and then what the consequences of those actions, if you take, will be. Okay, so that is prescriptive, right? So let me take the elections we are coming to do, for instance. Let me take both ends. Let me take MPP and NDC. So let's say that where I sit now, when I look at the predictions, the data that people are presenting, it's likely MPP is likely to lose based on the data. Please, one more because I'm saying MPP will lose. Me say that is how the data is presented. But it is not what is presented that matters. It is the actions that MPP might take which can perhaps turn around. Let me take NDC2, for example. NDC is also watching the data and say, oh, we are in the lead. We're in a comfortable lead. Nicely. You see, that is important, but it is the step that is taken to consolidate those grounds that matter. So from both ends, all of them are seeing the same data. But what do you think is how both of them are interpreting it differently? True or false, guys? Hmm?
True.
It's the same data, but interpretations are different. Somebody is interpreting to say, oh, we are in a comfortable lead. Another person said, yes, we are not in the comfortable lead. So what do we do? So it's what should be done about it that is more prescriptive. The prescription you give to what you see, you can all see the same prediction, but how you want to deal with it might vary. And we say that prescriptive analytics, if you have analytics which gives you options, that okay, if I look at it, currently this is the way the data is presenting itself. But if let's say MPP wants to turn the tide based on ABCD, they have to do 1, 2, 3, 4 to get it corrected. And then the prescriptive analytics will show you based on the course of actions and how the trend will go. Right? And then if you take, let me take the NDC perspective too. You have this, so and so. Okay, if we're able to do this and this and this, then we can do that. Then we can consolidate. So prescriptive is the highest form of analytics. In fact, if you're an organization, that's what you should seek for your organization all the time. Because your predictions are based on what is there, but predictions don't change your circumstances. Prescriptives will change your circumstances. So it's very important. Let me give a typical example. So I'm sure Nana will do clustering with you guys when you work with him. So let's take Accra Kumasi, Accra Takoradi Road, the Accra Cape Coast Takoradi Road. Have you seen that road? Guys, have you seen that road?
Yeah.
What is the common
Yes,
feature?
yes,
What's the common feature you see on that road?
A lot of curves.
A lot of curves. Okay, what else do you see?
Traffic.
Traffic. Okay, what else do you see?
Signpost of accidents.
Thank you very much. So you see, and you notice most of the places where the accidents are, it's in a dangerous corner or something like that. Risky overtakings, right? I like what you said, a lot of curves and stuff like that. So the curves are naturally telling us that you're likely potentially to have an accident. True or false? Yes. And we have past record which says that accidents are occurring on this road at this particular point. Okay. So to analyze that, you might do a bit of clustering. Clustering, you learn how to do clustering, K-clustering and stuff like that. So you can cluster the data based on accidents that have happened and say that this type of accident, if you get to this point, you are likely to get this type of accident. And this type of accident can lead to head injury or can lead to so and so. So potentially when somebody have an accident there, the potential that he's likely to get this type of injury is very high. You see it. It's a prediction. It won't change. It is as it is. That's the data is presented itself, and that's a prediction. But where it makes sense is that seeing these clusters and making these predictions, you can say that if the road and safety people put A, B, C, D, it will reduce accidents by this margin. That is what people will pay you for. In every organization, that's what they will be much more interested in. In your mining sector that you are talking about, if there are constant accidents, your bosses know there will be accidents because the data presents itself too much for them to know there will be accidents. They'll be much interested in potentially, based on this practice, accident will occur in the next 2 weeks and this type of accident. But they'll be very much interested in the prescriptions you give towards curbing that. That they'll pay you more. So that's why in most organizations, prescriptive analytics is the best and is what people are seeking for. Okay, great, wonderful. Any questions on the 4 types of analytics?
Okay.
Hello,
Sit down.
Doc.
Yes, please.
Please, I have a question.
Go ahead.
My question is, are there instances, even when you've analyzed data, that your results you got can be contrary to what actually happened on the field?
Yeah. Recently, I had a student. Let me show you. In fact, I had a student. He did his thesis, and I asked him a question: why his results were interesting, but he couldn't come out to. He analyzed e-levy, and when he analyzed the e-levy data, do you know what happened in e-levy? So rightfully, when e-levy started, the volume of transactions dipped. But after some few months, it started rising again. So you have a typical thing which goes up, comes sharply down, and it starts rising. But he was worried about presenting that results because it's not what people's perceptions are. Everybody's perception about e-levy is that it's failing. True or false?
True.
Unfortunately, when the guy presented the data, we asked him, why didn't you present this? Because the data is pointing somewhere else, not what people's perceptions are saying. The rate at which it's rising is not as it came down. That's true. But at least it's showing. And the guy said he was scared. I said, why should you be scared? We are data guys, and when you are data guys, we deal with data. We present it as it is. Don't be worried about it. Present the data and let people read the data for themselves. They can add their own interpretations to it. You get my point?
Yes, please.
Yeah. So you can have predictions being different from what everybody thinks. Perceptions are not and listen, that's a big mistake we make in this world all the time. How many people think they'll go to heaven and won't end up in heaven? Guys. Oh, everybody goes into the desert. Have you seen anybody? How many people come out of the desert and said, Charlie Mecha? But when the results comes out, sometimes it's very different. Is that not it?
Yes.
Please,
Yeah, people are too hopeful.
I learned something about data a long time, even before data analytics came into being. I've been programming and building systems for years. I will never forget what Prof. Andam and the others used to tell us. Your integrity is very important. If you look at the second step here, where I say is the most important step. No, it's this one. It's the first step. Your integrity is very important. The integrity of the data is very important. Look, if we had wanted to make money in excess, can you imagine those days when the Nigerians were coming for stuff? You build the admission system, you know everything behind. If every year I was just dashing 20 admissions, 50 admissions, do you know how much money I would have made? I'm asking you. I would have made a lot of money, is that not it? But where will my integrity be? In the world of data, the moment you compromise little, you are finished. Nobody will employ you. I'm telling you this on authority. Nobody will employ you. The day you fidget with the data and present a different story, you are finished. Because it doesn't matter how wild and sophisticated you can work with the data. Nobody will employ you. Because the truth will never be told by you. And nobody wants to make predictions based on wrong data or wrong results. Do you understand what I mean? Your integrity, these things, they are not part of. Okay, no, Matilda will teach you next semester on data privacy and ethics. I'm sure she will talk about that. So you understand, please, your integrity is very important. This one is not about analytics. This one is about you. Anytime you're entrusted with data, Oga, make sure that you present it just as it is. I mean, I don't care about, I've built systems which have transcend Kufuor, Atamils, Mahama, Ekufuado. I'm still here and I enjoy my work. And anywhere I go, people know, John, that's it. You cannot change you because your integrity is more important than any money anybody. Salt, when the Bible says when salt loses its taste, it is finished. You can't do anything about it. It's as useless as ever. So please, this is free advice to all of you. If you want to go this journey of data analytics, look at what ChatGPT tells you. 1 minute, let me just look at what ChatGPT always puts at the bottom. Those of you who use ChatGPT. Let me come in. What is he saying here? Somebody should read this for me. At the bottom.
ChatGPT can make mistakes.
ChatGPT can make mistakes. Consider checking important information.
Disclaimers are very important. You cannot, if you cannot do so, it doesn't mean that at all costs. You know, this thing has caused a lawyer in the US. There's a lawyer who didn't check his information and his license has been revoked. It will help you, but you also need to make sure that you keep your integrity with it. The tools are just there to help you. They don't solve your problems. They guide you to a point. So for instance, if you do your thesis with your ChatGPT, I don't have a problem. But if you can't use it well the way it's supposed to be and you come and dump any rubbish to me, I will fail you. I will tell you what it is. In fact, when you start, I tell you are using ChatGPT. Because I've used it so much to know the difference of, yet there are people who use ChatGPT for their thesis and you clap. I had one student like that. She used the ChatGPT for a thesis. It was excellent. But her data was clear also there. The GPT was more of a productivity tool for the person, to help the person, not to substitute his or her work. I mean, I don't see the reason why you should be struggling with coining nice English, or you you go and review something and then you have to struggle with how you paraphrase it. No, I don't think so. You can use GPT and the rest for those things to help you. But don't come back and then just use GPT to generate everything and then you have no references. I go to the reference you put there and the reference is not what the GPT is talking about. Okay, now that one na fail. So please, I don't have a problem you doing that, but like I've put it across, please make sure that your integrity is kept. Okay, let's move and then we can round off. I mean, today is an introductory, so I'm bringing everybody, please, those who are advanced, I'm bringing everybody to the same point before we jump on. Okay. Now, so this is the various analytics, and this is the step-by-step processes that are involved when it comes to data analysis, okay? So first of all, before you begin any data analysis, you need to understand the problem you are there to solve. That's why you need to have an analytical mind, okay? Please, understanding the problem is 50% solving the problem. I mean, though all of you do math, I've done mathematics before. If you don't understand the problem, you would think all mathematical problems have the same solution. They don't. Other than that, you see all proportion related problems and say, oh, if this is this less than this, so and so equals this. But then might not be the same. So understanding and defining the problem is very, very important. 2, setting clear metrics. For instance, what are your dependent variables? What are your independent variables? What are you looking out for? These things are very, very, very important. It is important you set your metrics clear. If typical business, they'll say, what are your KPIs you are looking out for? I'm looking out for the churn rate. Churn rate is how people are dropping off, right? Something like that. Customers are dropping off and stuff. I'm looking out for maybe a very specific KPI as, let's say, if you are dealing with inventory, you are looking at the volume of sales, you are looking at the gross profit, you are looking at the margin, you are looking at so you are clear on your metrics that, in fact, when you get a client in data analytics, when you get a client, one of the first things you need to do is to do a lot of research and talk to the client. Sometimes clients know their problems, but they don't know what they have to tell you. They can tell you their problems, but you have to research. You have to find out. So let me see. Okay, you let me finish this, then I'll go to that because the time is fast spent. Once you are clear on your metrics, then you will know what data you need. If you don't know what metrics you need to provide a solution to your problem, then you will know what data even to go gather. Now you know the metrics, okay, because I want to look at the cost of goods sold. Therefore, I need this data, that data, that data, that data. Then you can go gathering the relevant data. And once you get the data in, the rest of the process, as we know, it continues. You clean the data, you fix quality issues, you standardize the data, all those, the 3 steps, they begin to flow, right? Then you mind it, you analyze data, understand the patterns, all those things, you interpret your results, and you present your findings, okay? Good, thank you. So please, these are very important. I did not talk about the first two when I started. I was so much focused on the data side. But the first two are the antecedents to actual data analytics. Please, this part is as good as this part. The metrics and the problem issues are as good as this part. Garbage in, garbage out. You. All right, you'll find these things over there. Okay. So here I just try to narrow a bit down into the data analyst perspective, but it's not all these things you know. So here, so the guy who asked me about semi-structured data is at this point, I went a bit deeper to talk about the different data structures. So I took my time here. Okay, it has a well-defined structure. It can be stored in a schema. When we talk about a schema, it's like your typical table, okay? So you have, when we talk about a schema, we're talking about the structure, the metadata that is related to it. Like, for instance, let me give you a typical example. So if you have a table of student records, like maybe, let's say academic records, I will need fields such as student ID, exam index number, course code, course name, the marks, right? The grade, all these things form the schema that goes with it. I may need, in my schema, I may need several tables. For instance, I need a table just that holds just the grades, okay? I need a table that holds maybe just your registration information. I might need a table that just holds the student records in terms of your name, blah, 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 blah. And then use a relational thing to join the different tables based on the student ID, okay? When I can organize it that way, then I say I have a structured data format, okay? So typically you say, and that's why we say it can be presented in typical table manner with rows and columns. So that's structured data, like I said earlier on. These are all examples of them. So SQL database, spreadsheets, online form, they are straightforward. Sensor, GPS, RFIDs, and all those things come with very simple data which you can work with, okay? All right, great. Now, semi-structured, I've talked about it. I use the email thing to show there are portions of which are fixed and have schema. There are portions of which are not that way, okay? So they are not, some portions are rigid, others are not, okay? And you cannot, because of that, you cannot store them in your typical rows and columns, okay? And so we use a different approach to store them. Let's look. So these are example emails, XML issues and stuff. We will try to take a deeper look. Now, how do we store these? We store them using two main approaches. We have XML and we have JSON. What is XML? XML defines tags. Let me have okay, let me have chat generate some XML data on sales for me.
Doc, please, we cannot see this.
Oh, sorry, sorry. Let me share my screen now. Let me share my screen rather. Okay, let me go back. Let me start a new chat. Okay, so I said generate XML XML data on sales for me. Okay, so I asked it to do this for me. So he's trying to get a relevant. Oh, what is it? Let me see what I did here. Okay. Okay, so it's the same thing he's done here. Okay, let me pick what he's done here for you. So look at the data. It's using what we call defined tags. What are tags? So let me copy this guy. Slash file new save as. Let me save as an XML file.
So it's down there.
However,
Extensible markup language.
from an extra,
F
yeah.
Say that.
Anyway. Oh, thank you.
Bafompa.
Nyamisha pa. Alrighty. Okay, so let me just put it somewhere here. So I'll save this. Good. So this is what we call an XML. So look at something. So it begins with an open tag like this one, sales data. And then it ends with this tag. So normally you have something like this. Oh, sorry. Let me cut what is in the middle here off. Okay, so this is an opening tag. This is what we call a closing tag. So each tag has an opening tag and a closing tag, right? And then you start adding the records. Let me take the bottom two records off. So each record you add is like your typical table, eh? This is like your typical table. You know, your Excel workbook, big like that. So in here, let me do side by side. Let me do some side-by-side thing. Can you see both of them?
Yes.
Can you see both?
Yes, we can.
Okay,
Yes,
cool.
Doc.
So if this was this would have been my sales data as a table, okay, as a spreadsheet. Then in here is my sales records. So for my sales records, I'm going to have oh sorry, this is so for my sales record for this row, I'm going to have item, quantity, okay, price, date. Then the record will come. What is it? Widget A, right? 3/15 2024-01-15. So it's clear, right? So you have something like this. Then so this is how, and note, every time you have this, so this one record, you have a sales record. It has an opening tag and an ending tag. When I'm mentioning this one's 1111 like this also, it has an opening tag and an ending tag. Okay, I think you understand it. Do you understand it? So if I want to add more records, let me add the ones here. So this is like row number 2. Look at it. This is like row number 2. Are you getting me?
Yes, sir.
Please, is there anybody who does not understand what I've done? Okay, great. So this is how SMLs are structured. Why do we do this? mostly semi-structured data, because you might want to store, if you store in your typical Excel, like the binary might not make sense. So here, for instance, let me try and bring image. So let's say I have an image here, okay? Then I close my image here. So over here, because it's of this format, I can come here and then say that whatever was put here, okay, generate, okay, add a base 64 image to each record. I hope you'll be able to do that. Sometimes you'll get confused. Okay, let's see what it did for itself. Okay, so it's giving me some, good. It got me. So this is a typical image thing, right? So if this was my email thing I was talking about, so he's giving me this guy here, right? So I'll come here, and instead of this, he called it image item. Let me tap, oh, a minute. So this is it, right? So he gave me something like this to work with, right? And then the next one can be a similar thing. So we can store this data in XML, though it contains unstructured data, okay? So that is why we do that. It has some structured, some unstructured, okay? Clearly. All right, great, wonderful. Any questions, please? Any questions? Okay, if there are no questions, I move on. Okay. Then we also have JSON, right? So let me my chat GPT convert the data into, so I'm trying to show you the same data in a JSON format, in JSON. So this is a typical JSON format of the same data. All right, so let me copy this. Let me, this is my XML format of the same data. And then I say that new, I'm trying to save the data. So this, and I say save this as a, where's my JSON, brother? Where's JSON? JSON, J when JavaScript something. Oh, my friend, we could go now. .json. All right, so this is a JSON format of the same file, okay? So while this is the XML format, this guy is the same data, but this JSON. So if you notice JSON starts with sales data, and then it has a bracket here, right? A square bracket here. So beginning and ending this way. Then this one has curly brackets beginning and ending for each record, right? And each record you have this, and then the record that and that. Okay, are we fine? So guys, do you understand the difference between an XML and then a JSON, right?
Yes.
Okay, anybody who is confused, tell me. Okay. That's how I'm say there. Yes, please.
What's the maximum data you can store in a JSON and an XML? Is there a cap?
As far as no, there's no cap. There's no cap. Just store so space in best on there. But just that if it's too big, too, processing becomes difficult. I mean, it will process, but it will take time. You get my point? I mean, data is just like that. That's why big data, you can't use the normal. People always ask me, why do I like sophisticated machines? I mean, I've used different machines.
I've used Alienware. I've used oh man, now I'm using Lenovo. I'm tired. They say Lenovo is good. I think so far I'm beginning to like Lenovo than all the other machines I've had. So far, so good. All my other machines get very hot. If you process a lot of information, a lot of data, stuff like that, those machines, they are like typical gaming machines. They easily get hot. Who works in a server room? Hey, and you won't talk, eh? Melody, what is it? I'm brutal. What is it? Melody, you say you are confused. Why are you confused, Melody? Tell me which part you are confused. Melody. The whole show, which part of the show? From beginning of my lecture or what? Okay. Okay, so the JSON, and let me go over the JSON and the XML. In storing data, we have different formats, especially semi-structured data. And I've indicated ethical semi-structured data is like this, where you have like an image, and then you have this. This one, he's truncated the image. That's why you think it's this way. The one we picked here, the one we did a conversion on, it was this guy, eh? So this is a typical example, right? So if I'm to put the whole data here, it will be something like this, which is very big. If I'm actually to put the actual image file, it will be something very big. It's like this. So can you imagine this was how big the image file was? This was how big the image file was, okay? So it allows you to store this gibberish along with nice data, because you can't store it in your typical rows and columns. If I paste it in your typical Excel sheet, you get angry. That's what's in this sheet. In fact, sometimes you might even think the data is wrong when we give the sheet to you. Okay. So that is, let me just get back to the simple form. So you have something like this. Okay. Okay, all right. So in as much as I have this, so what I'm saying is that in here for XML, you have each record, maybe sales, and then the various, and XMLs work with open and closing tags. So you have an open tag, and then you close the tag. All other things, anytime you open a tag, you must close it. So you can nest other fields within the other tags, like sale. I want a sale record. Every sale record, by our understanding, should have an item, quantity, a price, a date, and then the image that goes with it. But because I'm able to store this, because I'm able to put the images unstructured, but if it's XML, it makes it easy to store. Right? Good. Are you still confused? So let me take this off. This is just one record of it. Melody, are you okay with just the one record that I'm showing? Reply back to me, or if you can't talk, just reply back to me. I want to know whether you are still confused about it. Christiana, what's up? Christiana, speak. Christiana, can you type? Your link is a bit bad. Your voice is a bit bad. If you can type for me, I'll be glad. Okay, so that is it. If you take a typical JSON to is the same, let me just have just the JSON with just one record. It's like this. So it's just opening and closing of the tags and trying to make sure they fall into a certain defined structure. So if you take this, a typical JSON, let me take this part off.
Let me just take this part. So you have sale with this tag, the curve bracket, square brackets beginning, and each record will have beginning. So instead of this guy beginning with sale like this for an XML, it's JSON will say begin with this and end with that, right? And when you are going to the next record, put a comma before you bring the other record. Okay, I think you understand that one. Guys, do you understand this?
Yes.
All right.
Yes, please.
Yes,
Yes,
Doc.
Doc.
Okay, when you watch the video, I'm sure you understand further. So, okay, thank you. All right, so I need to run that because you have another lecture with Nana. So that's how we store data, especially for semi-structured data. Unstructured data, it's gibberish. It's just gibberish. Now, how do we store unstructured data? So normally we use a database we call NoSQL database. Okay, NoSQL means non-relational. It doesn't do, you know, this student ID related to this and all of that, right? It doesn't do that. So, or sometimes we store them in files, in documents, things like that, right? So it's store and NoSQL databases. Let me take a typical MongoDB. It stores things like it stores it in an object format. We call it objects. So a whole video will be stored as an object. It's one unit. You can have several different, like for instance, you see the XML I have here. It can keep all this data as a collective and tag them as just one data. It's not dealing with what is inside the data, but it's dealing with it as a collective, as an object. So if it's a video, he doesn't care whether it's a video image, he stored it as an object. As for how he analyzes later, that one's a different story. Okay, great. So normally we use those databases to store that, right? Good. And they store them in objects. You do MongoDB in the second semester, okay, for a NoSQL database, and you practice and come back and do some of the things for us to see. So we've talked about this. So we talk about JSON, and there are many other file formats. XML I've talked about, JSON I've talked about, CSV, Excel. You know Excel yourself. CSV is comma delimited. This is a typical CSV. Let me bold it up. So this is a comma delimited. So between each record, they are using commas. So manufacturer, Akura, model sales, Integra, sales in thousands, 16,919. Year sale, what is it? Vehicle type, passenger, price in thousands. So this is comma delimited. So you are using commas. This is tab delimited. That means that between each field value and the other, we are using tabs. So this one is a tab. There's a tab. The space here is a tab. Okay. I mean, you can use different. So that's what we call a CSV file. Okay. So these are all different ways. As for the XML, I think I've explained it. And the good thing is that when you put them in XML and JSON and all those things, any programming language can read it. So that is why in today's world, we don't care about the kind of database, whether you're using Oracle, whatever it is, MySQL, we don't care. So far as we can exchange data in any of the JSON formats or XML formats, JSON preferably for a lot of people, we are fine. You can send me data when you are sending in JSON, I'll work with it. I don't need to know what database you are running on. It's useless for us to exchange data. No. The university exchange data with the banks largely through XML. For almost a lot of the APIs, they are using XML for data exchange. All right, great. For the data analyst ecosystem, I've mentioned a lot of these sensor devices, APIs. I've been making. Do you guys know APIs? Okay, so APIs help us to have a defined way we communicate with each other. So we say that when you are requesting for a student's school fees, send me his student ID, and then maybe the program he's coming to pay for. Once you send me, I'll return back to you with the amount And then I will also add the student ID just for confirmation and the program, and maybe the amount is how it's supposed, is it in dollars, is it in CDs, blah, blah, blah. I'll return all those information. So it's like a way we do exchange of data, okay? And normally, most of them we try to exchange in the form of JSON, right? And then other things. So, all right, great. Types of data. There are many types of data, and that's all in the ecosystem of the data analyst. Sometimes you may have them in databases. Sometimes they may be in data warehouses, okay? You may have them in data marts. And when Dana does data science, you go deep and talk about data warehouses and all of that, data marts and stuff. Then we have data lakes. So what's a data? Okay, let me explain a bit so you don't get confused. A data warehouse basically deals with so much data organized, like, let's say, let me give a typical example. Like, for instance, let's take EcoBank. EcoBank will have so much data that is coming from its mobile applications, some coming from its core banking applications, some coming from customer care, so they can keep them all in a typical, like how you keep a warehouse. We call that a warehouse, okay? So keeping them in different servers, that kind of stuff like that, organized that way. Sometimes within a particular data, like let's say the core banking application data, they might want to keep smaller units of the data where they keep, let's say, all debit information, so all credit information, so data marts are like your typical, it's a typical smaller portions of the data, but organized in that manner, okay, nicely. Then we have data lakes. Data lakes are what the world is now used to in terms of the huge, the GAN models, the ChatGPT, that's what they are doing. A lake, anything falls into a lake. So there is social media data, there is blah, blah data, there is one data, all of them are in. All right. Don't worry, I'm about to end for you guys. Okay. All right. And then we have big data stores. We talked about big data. Which languages are needed? We have query languages, programming, and we have shell scripting languages. So for the languages, we'll take a deeper look as we go ahead. So we have Python. We have talked so much about Python. So when we get to Python, you'll have a deeper view of it. You will learn about all the various plugins that come with Python for various things you can do. Then we have R programming. So, and then we have the shells and stuff which you can use for that. All right, that ends our lecture for today. I'll share the video with you. I'll put the video link on the V-class for you. I'll share it also with your class rep so that those who are interested can pick it, okay? All right. Any questions before we round up so you can go to your next lecture?
Doc, the introduction part, that exercise.
Yeah.
We have found a way around it.
I've done it too. Have you checked it? Class personality intro. I've done it. That was the first thing.
Okay.
You came with it. No worry, I'll call back.
Yeah, I came in it.
So check it. I've worked on it, right? It was putting you in groups, so I've taken the group formatting off.
Okay, all right.
Thank you. Any questions before you leave? Okay, so I'll share the video and stuff with your class, with Ransford, the link, and you can pick, okay, once it finishes on my machine. Okay. Thank you all. Have a nice day. We meet tomorrow in the afternoon. Bye.
Thank you, Doc. Bye.
Thank you too, Doc. Bye.